Welcome back, everyone. This is Mr. Allen. Today we are looking at completing the square. Now this is going to allow us to get our quadratics from standard form to vertex form. And again, it's one of these processes that we just have to learn how to do. And so here we go. So we have an equation here in standard form. And the first thing we're looking to do, if we recognize what vertex form looks like, we know we have to have that coefficient out front, and then in brackets an x squared plus or minus some term. So that's the first step. We get the 2 separated from the rest of it by factoring the 2 out, and we're factoring the 2 out of the first 2 terms here. So the 16x becomes 8x because the 2 has been factored out. Continuing on, now this is the big step here. What we're looking to do is get to the point where we can get in these brackets a perfect square. And so the first step of that is to figure out what else needs to be here with this x squared plus 8x to have a perfect square. Now it turns out that value is 16, but the way we get that is by taking the coefficient of the x, dividing it by 2, and then squaring it. So here it says divide 8, the x coefficient, by 2, and we're going to square it. But if we do that, we're adding in the 16 that wasn't there, or in fact actually a 16 times 2 that wasn't there. So we need to also subtract that 16 eventually times the 2 so that I get back to essentially a 0. I have a plus 4 squared minus a 4 squared. Obviously that's no change to what my original question was. And then what we're looking for is the 4 squared was what I wanted to have in the brackets. So the minus 4 squared needs to be removed from the brackets. Essentially, we're going to multiply it by the 2 out front, and we end up with negative 2 times the 4x squared. What's left in the brackets is a perfect square. So now we have a perfect square left in the brackets, and we can factor it. Factoring this, we end up with an x, the plus sign from the middle term here, and the 4, which is the root of 4 squared here. The remainder of the expression here is just some number calculations. Negative 2 times 4 squared. 4 squared is the 16. And then basically we can just finish that up. Negative 2 times 16 is negative 32 minus the 5 more, minus 37. And you see I've changed my brackets back now from the square brackets to the rounded brackets. One note here, often at this step right here, people will write in plus 16 minus 16. Of course, that's fine. What I find is when we get to fractions later on, it's nice to just leave it as the fraction squared, because the next step, of course, down here is to then take the square root of whatever this value was. And if we leave it as the bracketed term squared, the square root just kind of jumps out at us. We'll have to do the calculation for the other part later on, but at least we're not squaring and then square rooting again. We're just squaring and finishing up the question. So second example, we'll go through it a little bit more quickly because it is exactly the same set of steps. So standard form, I'm looking to get, again, the a value, the coefficient of the x squared out front of the brackets. So factor out the 3. I'm left with x squared minus the 2x. I had minus 6x. Factoring out the 3 leaves me minus 2x. Same argument now. I need to have the rest of my perfect square here. So I need a 1 squared, which is 2 divided by 2 squared. So it's 1 squared. If we're going to add that in, we need to also subtract it. Now the x squared minus 2x plus 1 squared part is what I want to have in my brackets. That means this minus 1 or minus 1 squared is extra. Obviously at this point, because it is a 1, I can pretty easily remove the square, but just keeping the same idea of how we did the previous question, I'm leaving it in for the sake of looking at it. The 1 squared, the minus 1 squared is now multiplied by the 3, so it's a minus 3 times 1 squared at the end. The square bracketed information is now a perfect square. It is x minus 1 squared, the minus coming from the negative 2x here. And the rest of this will just be calculated normally. I have negative 3 times 1 squared, so negative 3 times 1 plus the 11 on the end, which will give me a positive 8. And again, x minus 1 written in rounded brackets because we just tend to use the rounded brackets. So now we have this in vertex form. I'm going to go through one more and then just kind of show one last little thing. So sometimes it doesn't work out quite as nicely as the previous ones did. Here I have a 4x squared plus 12x, factor out the 4. That all looks good. But you'll see that on the next step, when I'm looking to find my missing term, I have a 3x. I need to divide that 3 by 2 and then square it. So essentially I have 3 halves squared that I'm adding in. I also have to, of course, subtract that 3 halves squared. The minus 3 halves squared still has to come out. So again, exactly the same steps as previous. Remove the subtraction. So we've subtracted out the minus 3 halves squared, but to do so, it has to be multiplied by the 4 out front. The brackets, again, now you sort of see x plus, so x from here, the plus from here, and the 3 halves from here makes up my perfect square. I then have minus 4 times 3 halves squared in the back here. 3 halves squared is 9 quarters. Didn't mean for it to work out quite that nicely, but of course, negative 4 times 9 quarters. In this section right here, because everything is multiplied and divided, the order in which I do them doesn't matter. So 4 divided by 4 is 1. And then I have minus 1 times 9 is minus 9, plus the 11 is positive 2. And that is my final answer. Now, as you're going through these, the one thing you always want to know is whether, of course, you're getting the right answer, whether you're following the steps correctly and so on. And of course, if you have questions and there's a back of the book where you can check them, that's fine. But Desmos is a really good tool for helping you with this as well. And so what I've got here, can I go back a step or two? In the first example I did, I'm suggesting in the end that this equation that I started with and this equation that I ended with, of course, are identical equations. And so if I slide that to the side, you can see that the minus 2x squared plus 16x minus 5 is this one. The the 2 times x plus 4 squared minus 37 is this one. And so these are the answers, this is the question and the answer to the first example, question and the answer to the second example, and the question and the answer to the third example is just down at the bottom here. And so if we just look at what we've got now, I have my original equation graphed here. This is the answer I got. And you can't quite tell, I guess, but if I turn this equation off, you can see that the two equations are lining up perfectly, which means they must have been the exact same equation in the end. So I did factor this, or I did complete this square correctly, and I ended up in this form. Those two equations are identical. Similarly, the starting equation for the second example was the 3x squared minus 6x plus 11, and my answer to the second one, you can see, is right on top of that. And so I know for sure they are exactly the same. I think Desmos is a tool that a lot of us aren't using nearly as appropriately or as often as we should. Same sort of thing here, 4x squared plus 12x plus 11. I was a little lazy, obviously, and didn't even change the 11 from example 2 to example 3. And then this is the answer to the third example. And you can see again, they are clearly exactly the same equation. So I just want to throw that in at the end to sort of remind us that this is why Desmos exists, so that we can do things like look at an equation, see the graph of it, understand what I'm supposed to be able to pull from it, and then also sort of learn from that is maybe the bigger issue. If I look at the original here, this is the good old x squared. This is my example, my answer to example 1, and you can see that my vertex is the negative 4, negative 37 that I would expect from here. You can also see that the graph is, maybe you can't see right here, but if I move this on top of the other one, you can see that the graph is going up twice as fast. because the 2 out front, and so on. So again, just a little reminder on the end there that Desmos serves more than a purpose of just doing activities, but it can be used as a learning tool for us as well, especially if we're getting stuck with things.